that's okay, but the course was designed to use the calculator. That's why we're using this calculator. Yeah, you can use the formulas. All right, so in this problem, I'm going back down to standard deviation here. In this, if you go, oh, by the way, here's the symbols. I hope maybe I didn't say this right. Sample variance is S squared. I might have said it backwards. The variance is S squared. Standard deviation is S. It doesn't show you that, but it's S. Standard deviation, sample, these are sample. Sample variance, let's write it all down. Sample variance is S squared. Sample standard deviation is S. Population variance is sigma squared. Population standard deviation is just sigma. So there we go. We have the formula, the symbols for each of those. So I just wanted to make sure we have that. So standard deviation is without the square in it, and that's the one that you see on your calculator. The variance isn't on the calculator. All right, so let's go up here. And we're going to do number 3 and 4 before we do number 1 and 2. I'll show you why here in a second. Find the population standard deviation. Population standard deviation. And the population standard deviation, the symbol looks like this. This one says find the population standard deviation. Once again, also the symbol looks like this. So let's put this data into L1. There's the data. So we're putting that into L1. (20, 18, 15, 12, and 24. By the way, I'm going to do number 4 also, and I'm just going to put it into L2 so we can do it all at once. I'm putting that data, this data, into L2. That data there into L2. 10, 26, 30, 16, and 21. And then I'm going to go to the calculator and show you. All right, now that I have that data into L1 and L2, we're going to go to stat, calculate number 1 var stat, same as the mean, and we're just doing L1. Don't put anything in the frequency list because we're just doing L1. And if you look right there, there's our population standard deviation. What did they ask for? Yes, population standard deviation, 4.11. 4.11. If I come back, if you look at number 3, population standard deviation, it said it's multiple choice, so I got 4.11 on my calculator. They just wanted to take it to 1 decimal place, 4.1. So let's do L2. Now that we have this in L2, they even marked the answer for us here in green. Let's see if we get 7.1 for L2. What, by the way, did everybody get 4.1 for that number 3? You put this data into L1.
Yes.
Okay, good. And we're looking, you put that into L1 and we're looking for this symbol right there, population standard deviation. So we're going to do the same thing, population standard deviation for this data, which was in L2. So So if I clear all my stuff, go to stat, just to show you L2, I put that data in there. Then I'm going to go to stat, calculate, one var stats, and I'm going to put L2 in there. Remember to put L2. L2 is right there. Just a second, L2. And it puts L2 up there for us, saying that's the one we want to do, L2. And 7.08. The population standard deviation is 7.08. So for this answer, I got 7.08. But they take it to one decimal place. All these answers are one decimal place. 5 or more, you add 1 to the underlying number, so I get 7.1. So here they took it to one decimal place. On the homework, they'll tell you, take it to 2 decimal places or take it to 1 decimal place. Now, a good rule, and we talked about this in the mean, a good rule is 1 decimal place more than our data. Do you see our data are whole numbers? So take your answer to 1 decimal place. Data is whole numbers. So take your since that means no decimals, whole numbers. So take it to 1 decimal place more. So take it to 1 decimal place. So that was 3 and 4, sample standard deviation and sample a population standard deviation. Okay, now let's go up to 1 and 2. I was hoping we get the same data. We don't. So I'm gonna do this. I'm gonna type this into L1 and I'm gonna type this into L2. By the way, population variance. This time it's not standard deviation. We're looking for this population variance. It's the same symbol, but it's squared. So let's type that data into L1 and L2. L1, 26, 28, 16, 23, and 20, 16, 26. All right, I have my data into L1 and L2. Since we're doing population variance also, we're going to take it 1 decimal place more than the data, so the answer is going to be 1 decimal place. So I'm going to do L1 first. Actually, I'm going to do L2 first because I already have L2 in my calculator, I believe. So I'm going to do number 2 first. Stat, calculate, 1 var stats. Do you see I have L2 already? And there's no symbol with sigma squared. So we have to write this number down, 4.1472. So remember that. I'm going to take it to 4 decimals because we need to take it to 4 decimals. 4.1472. Remember that. 4.1472. 4.1472. The symbol is sigma squared. So we have to take the sigma and then square it. So I am going to square, or you can raise it to the 2nd power or square it. I'm going to square this answer. The sigma, I'm going to square that. And this is what I get. So I'm coming back. And on the calculator, once again, we are looking for this answer. My calculator only gives me, this is variance. My calculator only gives me standard deviation. and it gave me, I already forgot the number, 4.1472. So on my calculator, then I have to put 4.1472 and square it, and I get 17.199. If I take it to one decimal place, I get 17.2. And sure enough, that's the one that has a green mark on it, 17.2. So your calculator will not do variance. You have to do the standard deviation and then clear out and then type it in and square it on your calculator. All right, so let's do number 1. Stat, calculate, and I have it in list 1, so I'm going to put list 1, second, number 1. And when I hit enter, 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 I get 4.2708. 4.2708. 4.2708. Let's see if I can remember that. I tell you, as soon as I 4.2708, if that's it. And then I'm going to square it. Hit square, and that's what I get. So number 1, when we used our calculator to find the population variance, it's not there. Variance is sigma squared. We have to find the standard deviation, .2708, and square it, and I get 18.23 rounded to one decimal place. It's just 18.2. Okay, so standard deviation is on the calculator. Variance, you have to square that number on the calculator to find your variance. All righty. Any questions on that? I'm hoping you guys are following along. Yes, you can use those formulas in the workbook, but we don't teach those. I mean, I showed you the formula. They're in the workbook, but we use the TI-84 to get through this course. I mean, that's a lot of that. I mean, that one of those problems on some of the data that they show. I mean, can you imagine having 20 numbers and finding the standard deviation? You have to take each of those data points and subtract it from the mean, and then square it. And then add them all. It would take you a half an hour to do one of the problems on the tests. All righty. So the same thing we just did population variance and population standard deviation. Now we're going to do just from a sample. So it's different. Sample variance is S square. Sample standard deviation is S. These are sample. And once again, up above, we had population variance, and it's sigma squared. Population standard deviation is sigma. So it's important to see, for sample, we use S squared. For population, we use sigma. So if we have problems that say find the sample variance and standard deviation, I always do the standard deviation ones first because they're on the calculator. Number 2 is variance. Is this 3? Is there a 4? Oh, there's more. Okay, so I'm going to do number 3 first. Sample standard deviation. The symbol for sample standard deviation is just S. Sample standard deviation. So I'm going to type all this data into L1. Stat number 1, and I'm going to clear my other lists. 25, 13, 31, 33, and 20. So hopefully you typed that into L1. Once it's into L1, we go to stat, calculate, 1 var stats. L1 is in there. And can somebody tell me what the answer is from looking at my calculator?
8.1.
Yes, and that's important. The sample standard deviation is the one with the S. This is the population standard deviation. The sample one is with the S. So it's really important that you're able to interpret which one we're asking for. They're asking for the sample standard deviation, and it's 8.17. If we round it to 1 decimal place, it'd be 8.2, right? So we're looking for 8.2 in that answer. Once again, like I said, it's important to be able to see that on the calculator and know the difference between sample standard deviation and population standard deviation. So on the calculator, I mean, it looked like this, the SX, but I mean, we're just looking for the S, sample standard deviation. Okay. And I'm going to do 1 on the top. I'm going to do number 1 on the top. Find the sample variance, and the symbol for sample variance. I don't know why my calculator, my computer's just, oh, there it goes. Oh no, something's clicking. Uh-oh, I see. Give me a second. It's not making a good connection. No, that's not it. My pen is messing up. Give me a second. This happened to the last one. Okay, I'm back. So we're looking for sample variance. The symbol for sample variance is S squared. So on the calculator, we're going to find S, and then we're going to square it. So we're putting all this data into L1. So if they ask for variance, you have to find standard deviation and squaring it. 25, 20, 19, 15, 31. So sample variance, stat, calculate 1 var stats. We're doing list A, list 1. And my sample is 6.16. 6.16. Oh, you got to. I take it 4 decimal places when I do that. 6.1644. 6.1644. I'm just going to clear it. 6.1644, and then I'm going to square it. That's what I get. So I'm looking for this, but I found this on my calculator. 6.1644. 6.1644. When I squared it on my calculator, I got 37.99. And if I round it to one decimal place, I get 38.0. There's my answer. So remember, variance, you have to take the standard deviation and square it, whether it's population or sample. Now, population is what it truly is. That's the whole. A sample is a part of that population. So in reality, you want to try to get your sample to match the population because it'd be as close as what it's supposed to be. All right, let's go down, see if there's any more of these examples I want to do. Let's see. Yeah, let's move on. And then they give you these shortcut formulas. Once again, I wouldn't even mess with these. I mean, there's summation formulas with frequencies times X. Oh, yeah. And they actually show you how to do all this. You have to find midpoints. I don't know what's simple. I'm just, if you go through this process, they're going to show you how to go through this whole process here. Not that I'm going to do it, but I just want to show you. This is frequency times the midpoint. So you multiply those together, multiply these together. 26, 3 times 18 is 54, and so on and so on. Then you take this one and square this. 1 times 64 is 64. 2 times 13 squared. 13 squared is 169. 2 times 169 is who knows what. I mean, it's a really, really crazy process. It's drawn out process. I mean, back in the day, people used to have to do this before calculators to find out the answer. So I don't recommend it. Yes, you can go through it, but I don't recommend it when the calculator does it for us. Now, this next formula, you need to put a star by it. You need to write it down on your formula sheet. This is on the test, and this is one of those that is on the final. I mean, this is, I think, the second question that's on the final that I know of for sure. CVAR, coefficient of variation. So if you look, the top is a sample. That symbol is the sample standard deviation. The bottom is the sample mean, the average. So CVAR is S over the average, the standard deviation over the mean times 100. Write that formula down because I'm going to ask what that formula is here in a second. As soon as I scroll down, I have this short-term memory loss thing. As soon as I scroll down, I forget the formula unless it's sitting right in front of me. That's funny. Okay, so coefficient of variation. And it's a way, by the way, it's a way to compare standard deviations to see if they're different from one another. So in this problem, it says the mean of a number of car sales in a 3-month period is 87. The mean, that's the average. This is the sample mean. This is remember, this was sample mean, and this is the symbol for population mean. So the sample mean is 87. What they're saying, you got to read these problems and understand. The mean is 87. The standard deviation is 5. So that's A. The mean is 87. Standard deviation is 5. Then it says on the second commission, the mean commission is that's weird. Oh, they're asking the mean commission is 5225 and the standard deviation is 773. So the mean number of car sales, and then it says the mean commission. So this is car sales, and this is commission. Compare the variations. Compare the coefficient of variations. When you compare two variations, that's the coefficient of variation. And if we scroll up just a second, just to look at that formula again, S over X bar times 100. S over X bar times 100. S over X bar times 100. So the S over here was 5. X bar was 87. The S on this side was 773 standard, and the average was 5225 times 100. And when we put both of these in our calculator, 5 divided by 87 times 100. I get 5.74. The other one, 773 divided by 5225 times 100, and I get 14.79. So this has a larger coefficient of variation compared to this one. And in this problem, we really don't do anything to explain the coefficient of variation much. I'm going to say that's like this is more of a math thing where you have to be able to just plug something into the formula. But once again, coefficient of variations is to compare two different types of standard deviations or variations. Do you see we're using standard deviations? And it's comparing the two with their mean, how far apart their data is. And the larger one has a larger variation. So even though the data is two different types of data, you can still do the coefficient of variation for each one. Now, the 24 is the same problem. Compare their variations. I'm not too worried about that. This is on your quiz, I think, this week. I'm going to go in there. It's either this week or next week. So let's make sure we put a star by this one, range rule of thumb. This is on the test also. So it's going to say, approximate, by the way, this symbol right here means it's an approximation. How do you spell approximation?
You just have the R and the O switched.
Okay, there we go. There we go. Approximation. I can't even see. So that's the symbol for approximation. So, and oh, can somebody tell me what this S stands for?
Sample standard deviation?
Yes, I just want to make sure we're all on the same page. It's S was the sample standard deviation. And so this is a way of approximating the sample standard deviation, not giving you the real standard deviation, but giving you an approximation. The approximation is always going to be what the range is divided by 4. And remember, over here on the side, the range is the highest piece of data minus the lowest piece of data. The range was the highest minus the lowest. So for this example here, we have this data. Let's find a standard deviation. They tell us it's 2.7, but let's put that into L1. Let's put this data into L1 and verify, just for practice, to find if that is the standard deviation. Stat calculate. Oh, I got to put it in the stat 1 edit into L1 first. 5, 8. 8, 9, 10, 12, and 13. So when I do put this into my calculator, go to stat, calculate 1 var stats. The sample standard deviation is 2.69. Sample standard deviation is 2.69. 2.69 rounded to 1 decimal place is 2.7. So my calculator said 2.69, rounded to 1 decimal place is there. Now the range rule of thumb, the finding, and by the way, the range rule of thumb is not finding the range, it's finding approximation for standard deviation. So it is the range divided by 4. The range is the highest piece of data minus the lowest piece. 13 minus 5 is 8. 8 divided by 4 is 2. Do you see? This is an approximation. This is an approximation for the standard deviation. This is the real standard deviation. So they're close, 2.7 and 2, maybe not that close, but it's just an approximation. So on the homework, by the way, not the homework, well, it's going to be on the homework also, but on the quiz, this is, for some reason, this is a question people miss a lot. What is the standard deviation using the range rule of thumb? And then it's going to say, find the standard deviation, and then find a standard deviation, use the range rule of thumb. So you're going to have to do it twice. One using the calculator, like we just did, and then one using the formula for the approximation. This formula is called finding the standard deviation using the range rule of thumb. You find the range and you always divide it by 4. All righty. And range rule of thumb can be used to estimate the largest to smallest data values. Not to, it just tells you you can use the range rule of thumb as an approximation. There's this formula that we're actually going to look at later on. I think we're going to look at it in 3.3. This is the mean. Don't forget, this is the average minus 2 times the standard deviation. So get used to looking at those symbols and saying, oh, this is what it is. This is what it is. All right, this is the next one. This is a little bit confusing, this section. We're going to do measures of variation using Chevy Chevs. Chevy Chevs. So we're still measuring variation, but we're using Chevy Chev's theorem, okay? So, and by the way, this is the formula for Chevy Chev's theorem. 1 minus 1 over k square, where k has to be, it tells you k has to be greater than 1, and k is the number of standard deviations for Chevy Chevs. So when we see the word k, it should be a lowercase k. Mine look uppercase. This is the number of standard deviations using Chevy Chevs. Chevy Chev's theorem. Okay. And what's great about this is you can use these notes on your tests and quizzes. Don't forget, we've taken major quiz 1 and 2. The next thing we're going to take is major test number 1. We're taking test number 1, I think the end of next week. So really understand this material. Don't think, oh, I got another week to do the home. Do it now and understand it as far as how to type these things into your calculator and get it done. So Chevy Chevs, just to show you, Chevy Chevs is used in when data looks like this, when it's not symmetrical. Do you see some, it's skewed right or left. This is skewed right. Can you, so if I say skewed right, is there another way of saying it skewed? Skewed right also means positive skewed. Thank you very much. Positive skewed. Skewed right and positive skewed are the same thing. Remember, skewed left and negative skewed are the same thing. So we use Chevy Chevs when our data is not symmetrical. We'll use something else when our data is symmetrical. When our data is nice and symmetrical, we're the same half on both sides, we use something else. But Chevy Chevs, we usually use it when our data is not symmetrical. And you can't use one standard deviation they showed you up there. So 2 standard deviations, if we look at Chevy Chev's data, by the way, in Chevy Chev's, they show you the average is right here. Do you see? That's the average. And if you go the same distance on both sides of the average, Chevy Chev says 2 standard deviations. So this is kind of important. Chevy Chev says 2 standard deviations. If we say 2 standard deviations in Chevy Chevs, that's 75% of our data. 3 standard deviations is 88.89% of our data. And then a little further down, 4 standard deviations is 93% of our data. And they get it from that formula we said. Formula was 1 minus 1 over k squared. So if we put a, this is k, if we put a 2 in there, 1 minus 1 over 2 squared, 1 minus 2 squared is 4, 1 minus 1/4 is 3/4, and 3/4 is the same thing. And when I put in my calculator is 0.75 or 75%. If I put, uh-oh, my pen just messed up again. How does that happen? I might have to buy me another one. If I put 3 standard deviations in the formula, 1 minus 1 over 3 squared, 1 minus 1 over 9, I put that in my calculator. 1 minus 1 divided by 9, I get 0.88888. Do you see? And round, if 2 decimal places, 3 decimal, or oh, if you multiply it by 100, I get 88.88888. And 2 decimal places, you add 1 and you get 0.89. So the decimal equivalent is 0.888. Percentage is 88.888. You had to multiply it by 100. And so on. The same thing is for 4 standard deviations. 1 minus 1/6 on my calculator is 0.9375, which is 93.75%. What that's just saying is, what that tells us, and it's really good to understand 1 standard deviation, or by the way, Chebyshev's, it's set up there. You can't do 1 standard deviation. You have to do at least 2. 1 standard deviation is not allowed. Well, you can't use 1. You can do more than 1. You just can't do 1. So do you see right here is 2 standard deviations. 2 standard deviations, they're saying 75% of the data 75% of the data falls into this, between these 2 spots. And here is the average plus 3 standard deviations on both sides of the mean. Don't forget the average is right there. 3 standard deviations from the mean, it goes to this spot and this spot. 3 standard deviations this way, 3 standard deviations this way. 3 standard deviations is almost 89% of the data. 89% of the data. So it just tells us how much data is within the mean, certain standard deviations away. And if you listen, even the polls, when they do these political polls, they say, we have a 75% chance of being within 1 standard deviation of this data. You know, this poll it has a 75% chance of being within 1 standard deviation, or they'll tell you, oh, plus or minus 2 standard deviations. So you'll actually hear these words. What they're telling you is how spread out your data is. So Chebyshev's, we're using that formula. Let's take a look at this. It says from the example, for this example in which variable 1 has a mean of 70. So we have a mean of 70, an average of 70. So we can, I don't know if it's a sample or standard deviation. Normally we do sample. And a standard deviation of 1.5. We're doing Chebyshev's in this because they're talked about Chebyshev's. 1.5. Standard deviation for Chebyshev's is K. And they show you where your data falls within the range. And here's that one formula that they give us. They didn't. Oh, it's at the top. Let's look at that formula again. Here's the formula. The smallest data is the average minus the number of 2 times the standard deviation. And then here it's the average plus 2 times the standard deviation. So if we look at our data here, let me bring it down here. There we go. Let me clear this off. Once again, our mean is 70. Standard deviation is 1.5. It's the average plus, or the left side is minus 2 times the standard deviation. And I'm using K because we're doing Chebyshev's. And then we have the average plus 2 times the standard deviation. The average is 70, and Chebyshev's, we said standard deviation is 1.5. Here, the average is 70, and we're doing 2 times the standard deviation, which is 1.5. 2 times 1.5 is 3, so it's 70 minus 3, which is 67. That's the low end right here. That's the low end. And the high end is 70 plus 3, which is 73. So our data, 2 standard deviations, what they're saying is 2 standard deviations, our data falls between, not 2 standard deviations, 1.5 standard deviations, 1.5 standard deviations, our data falls between these numbers, 67 and 73. So for 1.5 standard deviations, our data will fall between those 2 numbers, the low end and the high end. So we're going to do the same thing here in this problem. The average price of a house is 10,000. The average price of a house in our neighborhood is 50,000. So the average is 50,000. One standard deviation is 10,000. Find the price range at least 75% of the houses. So in Chevys, and by the way, on the homework in the test, they'll say use Chevys, or they'll say it's not symmetrical. So using Chevys, 75%, go back up. You have to remember that up here, 75% was 2 standard deviations. Right here, 75% was 2 standard deviations. So you have to remember that. So our average plus 2 standard deviations times, or 2 times the number of standard deviations, then the average minus 2 times the standard deviation. So the average is 50,000. I should have did a small one on the left. 2 times standard deviation for this is 10,000. So the high number is 50,000 plus 2 times 10,000, which is 70,000. And the low number is 50,000 minus 2 times 10,000. 50,000 minus 20,000 is 30,000. So the price range within 2 standard deviations, like we said, 75% of our data, 75% of the homes sold in this neighborhood will be between $30,000 and $70,000. I know it's a spread, but that's where 75% of the data is. Some houses will sell for more, some will sell for less, but that's where 75% of the houses sold. That's the price that they sold for. That's what this is. So definitely write this down. This is the high end and this is the low end. The high end is when you're adding it. The low end is when you're multiplying it. Standard deviations go inside of here. It's always going to be a 2, but the standard deviation, whatever we're using for standard deviation, goes inside there. Let's see how many more we have. This is a tough one. I don't think you're going to have that. I think I'd rather do these down here. Let's just do one of these. Let's see. I see that one. Let's do this one. This is a tough one too, but it's a little different. Okay, so we'll have to look at that. The mean is 80. So for this, we're doing number 2. The mean, the average is 80. Standard deviation Standard deviation equals 10. So we have the low and the high already. It says what percentage is in the low and the high. We have the low and the high already. The low is 65. The high is 95. Remember, the formula is x plus 2 times whatever k is the standard deviation for Chevy Chevs, x minus 2 times k. Now, there's x is 80. I mean, we can actually find the answer without doing a little bit of math. If our average is 80, how far is the high away from the average? How many standard deviations? Do you see our average is 80? Here's 80. How far away is 95? One standard deviation is 10. So how far away is 95?
$15.
Well, close. It's 15 away. But do you see one standard deviation is 10? So if I go one standard
1.5.
deviation this way, yeah, so I get to 90. To get to 95, I'm 1.5 standard deviations away. Do you see 95 is 80 plus 10, and then a half more of this is 95. The same way goes for the other side. If I subtract 10, I get 70. I subtract a half, I get 65. Do you see? That's where we get this 65 and 95. So we're 1.5 standard deviation away. So we're not done. It says we need to find the percentage. And the formula for percentage was 1 minus 1 over k squared. 1 minus 1 over k. K was 1.5 standard deviations away. So let's put this into our calculator. And then, by the way, that's the decimal equivalent. Then you have to multiply it by 100. 1 minus 1 divided by 1.5 squared. So, I mean, that's kind of tough. When I put this in my calculator, this is what I get. Hopefully you guys get this. 1.55. 1 minus 1 divided by 1.5 squared. You should get 0.55. And if you multiply it by 100 to get the percentage, you get 55.5%. Or actually rounded to 55.6%. So the question is, using Chevy Chevs, at least what percentage of values fall in this range? 1.5, the standard deviation is 1.5. The percentage is about 55.6%, or you can say 56%. So, I mean, there was a lot involved there. You had to figure out what the K was, and then you had to figure out what the percentage was. Once you had the K, you could find the percentage. So definitely write down Chevy Chevs. This is the other formula we had. We just had this. It didn't show you the percentage, but this is how you find the percentage, and then you just multiply it by 100, and then you find the percentage. 1 minus 1 over k squared. K is the standard deviation for Chevy Chevs. We had to realize that it was 1.5 standard deviations away on both sides. You plug it in and then find that percentage. All right, this was another long lecture. It's a tough one. That's why I said I could only do one at a time. Oh, was there more? Oh, the empirical rule. This is actually in the next lecture. So they just wanted to introduce this to us really quick. The next lecture is about the empirical rule. The empirical rule is what happens if our data is symmetrical. See how on the average in the middle, it is symmetrical on both sides. And in the empirical rule, they show you one standard deviation. It's different from Chevy Chevs. Two standard deviations in Chevy Chevs was 75%, but in the standard rule, in this empirical rule, two standard deviations is 95. You can't do one standard deviation for Chevy Chevs, but for the normal curve, it's 68%, and three standard deviations down at the bottom is 99.7%. And we're actually going to cover that in 3.3. So I'll do that video tomorrow morning, and I'll post that. Make sure you watch that before this weekend, and also do that 3.3 homework. So you have quite a bit. So you have one video to watch, 3.3 before Sunday, and then you also have the 3.3 homework. All right. That was once again, it's a lot.